Hi guys, so this tutorial is titled Measuring Acceleration, but I'm going to cover a couple other things just as a quick review first. So first of all, here are some definitions that all relate to each other. You have to know each of these definitions in order to know the one underneath it. So first of all, you need to know that motion is a change in position over time. Speed is a measure of the rate at which your motion is changing. So it's the rate at which your position is changing. Velocity, very similar to speed, but it also includes direction. Acceleration is any change in velocity. So if your speed or direction changes, you're accelerating. Okay, so what we need to do now is look at a couple of math formulas that help us calculate these three things, because they're all numbers, right? How fast you're going in a particular direction, and how quickly you're speeding up or slowing down or changing direction, all of those things can be represented with numbers. We're going to spend a lot of time practicing calculating these things and using these formulas, so you don't need to really get carried away. I just want you to be introducing yourself to them right now. Here's the deal. Speed, or what we call average speed, is measured by taking the total distance you traveled and dividing by the total amount of time it took you to travel it. So you take your total distance and you divide by your total time. So here's what the formula looks like. Speed equals distance divided by time. Remember that slash, you can say it as per, or you can say it as a divisor sign. You can say that it means to divide. Velocity has the exact same formula. You just have to remember that if you're going to call something a velocity, you better include the direction it's moving in. That's easy to forget. Acceleration has this incredibly scary looking symbol in it. That's the Greek symbol. It's a Greek letter, and it's the Greek letter D, which is in Greek delta. So it's the Greek letter D. It's actually the capital, and it's delta is the name of it. And in math, we use this symbol to mean the change in. So whenever you hear me say the change in something, I'm going to use that triangle. When I draw it by hand, it kind of winds up looking like that because I'm not very good at it. But that's the idea. It's supposed to be basically a triangle. Sometimes you'll see it with curved edges like that. So acceleration is the change in velocity over time. In other words, you have to figure out how much your velocity has changed from 1 second to the next. Down the road, I'll be asking you to solve word problems like the ones you see on this page using those formulas. And we'll get a lot of practice with this in class. But basically what I'll be looking for you to do is to know what formula you need and then plug in the numbers. So in the first one, Joe's car is traveling 300 meters in 10 seconds. What's his average speed? Well, you need to know that this formula for speed is S equals distance divided by time. So you would write that, and then you'd just plug in the numbers you were given. The distance is 300 meters. Notice how I include my units when I do this. Divided by the time, which would be 10 seconds. And then when I calculate that out, I'm going to get 30, and my units will be meters per second. And those are units of speed, the ones that we're going to use. In the second problem, it's the exact same problem, only instead of asking for speed, it asks for velocity. So it'll look exactly the same. I'm going to write S equals d over t. Actually, I'll probably write V equals d over t. Hold on. V equals d over t, right? Because it asks for velocity. And then I'm going to plug in my numbers. They're the same numbers as before, 300 meters in 10 seconds. And so I'll get the same number, 30 meters per second. But now I have to also write down eastward in order for it to be a velocity. For acceleration, you're going to need to write the acceleration formula. This is where you get to draw a delta, because acceleration is delta, the change in velocity, v, divided by time. So what's the change in velocity? Well, you need to go look and see what was your starting velocity, what was your ending velocity. We started at 20 meters per second and we ended at 32. So that's a change of 12. So the change in velocity is 12 meters per second. and the time it took to do that was 3 seconds. So now you can see 12 divided by 3 will give you 4, and your units will be meters per second, which we said we could write as meters per second squared. Now, that happened really quick. I'm just introducing you to the fact that eventually you're going to need to use these formulas like this. Right now, what you want to do is memorize the formulas and make sure you know what the symbols mean and what the letters mean. Tomorrow in class, what we're going to do is we're going to measure acceleration using a tool on your iPad. The tool, which is called Vernier Video Physics, will create something called a ticker tape diagram. Unfortunately, this is kind of a dated term, ticker tape, because you guys don't have ticker tapes in your lives very much anymore. But this is kind of a ticker tape. It's the little small piece of paper that they make receipts on a cash register. They used to be even more narrow than that because they used to be used for things like telegraphs. A telegraph was a very old-fashioned way of communicating from a distance, and it used to type out information inside of here, and it would come out on the ticker tape, which is this really narrow piece of tape, which is just a piece of paper. And for a while, right around World War II up until through like maybe 1965 or so, these ticker tapes were all over the place in any office building in America, just like iPads are everywhere now. And so there was something called a ticker tape parade, which looks like this. Just trying to get this out of the way. There we go, so we can make that bigger. That's a ticker tape parade, and you see all the little pieces of ticker tape flying through the air. So anyway, that's all just so you know what a ticker tape is. These are ticker tape diagrams. What they do is they make a long line of the motion that you're seeing, and each dot that you see on the line on the ticker tape is spaced 1 second apart from its neighbors. So every second that the ticker tape runs by you, it's like you're putting a dot on the page wherever it lands after 1 second of it moving past. So you can kind of imagine that you've got your finger balanced right here. Whoops, always doing that. Right here with a pen ready to go, and this ticker tape just kind of moves this way at a rate that's constant, and every second you're putting a dot on the page wherever it happens to land. And so if the dots are equidistant, if they're the same distance apart, that means that the speed is staying the same. It's a constant speed. But if the dots are getting closer together or further apart, that means that the object is accelerating. Because if the dots get further apart, that means that from here to here, let's say, there's more distance being covered in 1 second than there was from here to here. That's a small distance that got covered in 1 second. This is a big distance that got covered, and this is an even bigger distance that got covered in 1 second. So this is what ticker tape diagrams do. They show you at a glance how quickly something is speeding up or slowing down, or if it's maintaining the same speed. If you compare the ticker tapes for two objects, you can tell which one was moving faster and which one was moving slower. Both of these objects are not accelerating because the dots are equi-spaced between each other, but the top one is moving faster than the bottom one because the dots are further apart. Well, what if I wanted to draw a ticker tape diagram of an object that was slowing down? Well, then the dots would be getting slowly closer and closer together, like this. Until finally, the object is standing still and the dot keeps appearing on top of itself because the object's not moving anymore. So that would be slowing down, or what you might call decelerating. You should always put an arrow showing what direction your ticker tape is moving in. The ones that I've shown from the pictures that I grabbed off the internet don't have those arrows. And it doesn't matter if the speed is constant that much, but you really should include an arrow if you're trying to show somebody that this, for example, is slowing down, because if it goes the other way, it's speeding up. The tool that we're going to use, Vernier Video Physics, will actually put these dots down on the page for you. You have to tell it that you want it to track a particular object, and then it will track it throughout the video that you took, and it will put dots down at every second interval, and then you'll be able to see if it's accelerating and compare its acceleration to the acceleration of objects on the same screen with it. So it can be a pretty interesting tool. And that's one of the things that we're going to do together in class on Friday, is learn how to use Vernier Video Physics to take videos of our mystery ramps so that we can actually see what's accelerating and how quickly and so on. Okay guys, see you in class.